In notes 6.2, example 15, we're going to use right triangle trig to determine, in this case, the height of a tree. So the problem says Frank needs to know the height of a tree. From a given point on the ground, he finds that the angle of elevation to the top of the tree is 36.7 degrees. Then he moves back 50 feet from where he was, and then he looks up, and from that point, the angle of elevation to the top of the tree is 22.2 degrees, and we're asked to find the height of the tree. So remember, the angle of elevation is always measured from the horizontal. So this would be an angle of elevation. So this here is an angle of elevation because it's above the horizontal. So we start with the horizontal, then we're going to go up. So let's make a sketch. So I'm going to draw the ground. And then let's say that this is our tree. And we are figuring out what happened to Frank. So he's standing somewhere. So let's say he's standing here. He looks up to the top of the tree and he measures the angle of elevation. So that is the distance from the ground, the horizontal, the amount of rotation up to his line of sight. So this right here is 36.7 degrees. And then he moves about 50 feet and he looks up again to the same point. So we're going to draw another line. And this distance here from where he was standing initially to where he looked up is 50 feet. And then the angle of elevation from the second viewing point is 22.2 degrees. And we want to find the height of the tree. So I'm going to call this distance, the height of the tree, I'll call that y. So let's start solving this problem. So initially, we're going to look for right triangles. We actually have two of them here, so I'll draw this in here. So we have this right angle. So we have a smaller right triangle. I'm going to highlight that here in yellow. And then we have a larger right triangle, which I will highlight in green. So we're working with two overlapping right triangles. So let's look at the yellow triangle. So the yellow triangle has, this angle is 36.7 degrees. We know the length of the opposite side, well, we don't know it, is y, and the adjacent side, I'm going to call that x. So I'm going to set up a ratio using tangent. So tangent of 36.7 degrees is equal to the ratio of y over x. That will be the opposite over the adjacent. We can do a similar analysis with the green triangle, this larger triangle, and then we're going to be focusing on the 22.2 degree angle. So once again, we can use tangent, so we can say tangent of 22.2 degrees is the length of the opposite side, which is y over x plus 50. That is the horizontal portion of the green triangle. And you'll see now we have a system in x and y that we can solve. So let's solve this by substitution. I'm going to isolate y in the first equation. So y is equal to x tangent 36.7, and then we can substitute in for y in the second equation. So that'll give us the equation tangent 22.2 degrees is equal to x tangent 36.7 over x plus 50. And remember, tangent 36.7 and tangent 22.2 are constants. So the first step, we want to start isolating x. We'll multiply both sides of the equation by x plus 50. So if I multiply by x plus 50 on both sides, the left side will become x tangent 22.2 degrees plus 50 tangent 22.2 degrees is equal to x tangent 36.7 degrees. This is actually a linear equation. So in a linear equation, we want to put all the terms with x on one side and the constants on the other. So I'm going to subtract x tangent 22.2 degrees from both sides of the equation. So I'll have 50 tangent 22.2 is equal to x tangent 36.7 minus x tangent 22.2 degrees. To isolate x here, we'll need to factor it out. So I'm going to factor out x on the right side of the equation. So that will give us x times tangent 36.7 degrees minus tangent 22.2 degrees is equal to 50 tangent 22.2 degrees. And tangent 36.7 minus tangent 22.2 is a constant. So let's divide both sides of the equation by that constant, tangent 36.7 degrees minus tangent 22.2 degrees. We'll do that on both sides. So we will get that x is equal to 50 tangent 22.2 degrees over tangent 36.7 degrees minus tangent 22.2 degrees. If we enter that in a calculator, we'll find out that x is 60.5 feet. So that's the piece here on our triangle. But we really want to know why. So we can figure out y from our original equation. So we can substitute in here. So y is equal to x tangent 36.7 degrees. So that's going to be 60.5. And really keep that value in your calculator. Don't round it off yet. So y is the height is going to be 45.1 feet. So the tree is 45.1 feet tall.